Live from New York, it's Ask These Engineers.
Hey everybody, welcome to Ask an Engineer. This time we've got two engineers for you, double the pleasure, double the fun. It's me, Lady Ada, the engineer, and with me is Bunnie, Andrew, Bunnie Wang. And we're here at the Adafruit factories where we do design, engineering, manufacturing, electronics, all the stuff that y'all love about doing DIY maker electronics. It's happening here, and today we've got this special guest. So we're gonna have
Yeah, look at that.
a lot of bunny time. This is going to be the state of the bunny.
Yeah. Oh. All right, well, I'll help move things along. Maybe, Bunnie, introduce yourself.
Yeah.
Introduce myself.
Yeah.
Yeah.
I'm Bunnie. Hi. I like to build hardware. A lot of it's open. Most of it is, I'd say.
And
Yeah.
you're visiting here.
I'm visiting it. I'm based in Singapore, and I'm here in New York for a little bit, and I thought I'd swing by. I mean, I love touching base with you and catching up and seeing how things are going, and like every single time I come, you like grow and grow and grow. It's like you're taking over, and it's...
And you brought some cool demos that you're going to show
Yeah,
off.
yeah, yeah,
Okay,
yeah,
so
yeah.
stick around.
We'll reminisce from some of the old days when you visited us 7 years ago. We'll get to this later.
Yeah, yeah.
Some people might
Wow.
be wondering,
Yeah.
who is this bunny guy? What's this guy done?
Yeah.
What have you done recently? What have you done in your life? Well,
Jesus.
this is your life.
Well, let's
Oh,
start.
Jesus.
So a lot of people, and take it away, lady, probably know Bunnie from hacking the Xbox.
Yeah, what is this all about?
I've always liked to take apart my stuff, right? And around 2000, 2001, the Xbox came out, and I started taking it apart. And then I found out that there was laws passed that made it like potentially not legal to take it apart. And then
Which only made you more excited.
which made me more. Yeah, I was like, really? Let's see what happens here. So I started digging into it, and with a bit of perseverance and a lot of luck, managed to extract some crypto keys out of the box, and a bunch of stuff happened after that. EFF came in and helped, and then a nice story came out of it, how I reverse engineer it and how everything happened. And originally a company, I think it was Jay Wiley, commissioned me to write Hacking the Xbox, and then I finished the manuscript. They reviewed it by the lawyers and said, we can't publish this.
Which is interesting, right? Because isn't there supposed to be like freedom of
Yeah, there's
speech?
supposed to be freedom of speech and First Amendment and all sorts of stuff. But the nice thing is they let me keep the advance. And so I took the advance, I printed a bunch of books. Mm-hmm. And this was my first foray into any sort of like kind of business sort of thing. So it was like hilarious. I have like this garage, and this truck pulls up with a pallet full of books. I'm like, now what? And I have to like figure out how to like take orders and take shopping carts and all that sort of stuff. And there's like a while I'm like packing books, and that's before the version that's being shown here, which is the version by No Starch Press. Printing and packing books was fun for about a month. I got tired of packing envelopes, so I wanted to get back to hacking. And so then No Starch Press was run by Bill Pollock, who's like an amazing guy. He's like, I run No Starch. I'm the final say. I'll totally take the risk in printing this book. I think should be out there. And I was like, have at it, right? And so he created...
Well, but the best thing and the worst thing that could happen is that he does get sued by the government or
Right.
Or, like
Right.
it's like all it does is make it even more popular.
Yeah, I guess so. And so he took over the printing of the book, and so that's the version that you see here that's featured.
And what kind of stuff is covered in it? Is it like hardware, software? Like what kind of hacking do you cover in this?
So the subtext of the book is an introduction to reverse engineering. So really the book is about reverse engineering and how to get into reverse engineering. And what I wanted people to do was I actually used the Xbox as a lens to get people introduced. The nice thing about it is that say you want to learn reverse engineering, you could go like, okay, buy this weird model VCR or DVD player, and then like we do something specific on it. But the Xbox can buy everywhere, right?
You can still buy them.
Yeah, you can still buy them, right? And so I'm like, okay, if you want to learn reverse engineering, here's a common platform to go with. And first, let's just like change out the LED in the front panel. Okay, now let's get a little more advanced. Let's get more advanced. And so you kind of like pull people along, and you can talk about different things, like what do you look for and how to understand the box. And finally, we get into like much more advanced topics. And so really the book is, I use Xbox as sort of like a mechanism to like introduce people to how to get into the mindset, how to reverse engineer, how to think about, opening the box, owning your hardware, understanding how it's made. And eventually, that gets you into the point of being able to do other things.
The thing that's interesting about reverse engineering, and just because this has happened so recently, and we'll talk more about DMCA stuff, is it seems like you are really into freedom of information, getting people educated about the electronics they own, and hacking is it's a clever way to in a sense, like trick people into having deep understanding of the electronics around them.
Right. I think that so.
This is like a theme.
Yeah. For me, I think the term hacking is how do you say it? For me, it just comes from curiosity of knowing the world around me, and then I would do it, and people say, "Oh, you're a hacker," and I'm like, "Okay, well, I'll adopt that label because that people understand kind of what that means."
Also, we come from like this MIT culture where hacking
Yeah.
it's not like a breaking into a computer sense,
Right.
but a making technology do something it was not intended to.
Right, and so the way I like to say hacking is like you see, a piece of metal for a piece of metal, and not like the licenses and restrictions around it, right?
Mm-hmm.
And so you're crossing abstraction boundaries. Normally, this is supposed to be a box; you're not supposed to open it. But when you see what's behind it, all of a sudden you can see a dozen different applications for this that was not originally intended, and so you get a lot more utility out of the things that you have, right? It's not.
So like an Xbox, it's a video game player, but you're like, no, it's not. It's
also a Linux PC, right?
Yeah, okay.
For anything else that you need or whatever it is. And so when you're willing to go past you bought a video game box, but when you open the lid and you see on the inside it's just a PC, all of a sudden I also have a PC. And so you've hacked it, but you're actually getting more utility out of the things that you own. And I feel like the more you understand about the world, the more you realize that like a lot of things are interchangeable, a lot of things are more powerful than they really are. And if I buy something and I own it, I would like to get all the utility I can out of it. And so I feel like the more people understand this, I think the more people are empowered, and the less people are just droning along and just buying things and just having. Like one of my biggest fears is that like we become slaves to technology at the end of the day. Like we are like, oh, technology is magic, and it should be run by this cabal of people who we trust, and there's no way we can understand it, right? And then all of a sudden, like, you're disempowered, disenfranchised, and so I think it's really important to let people know, hey, like, you can open it, and you can like understand what's on the inside. You shouldn't be afraid of it. You don't have to do it, but here's a path forward, and you can always walk it if you want to walk it. Yeah.
We're going to be touching on more of these kinds of topics, but now let's take another detour into the past of Bunnie with the Chumby. So this is a project that you worked on just after you graduated about.
Yeah.
A little bit?
Pretty much. It was like sort of. So what happened was I went on this arc of doing silicon for a while. I was like getting into like doing like actually designing chips, and then the problem with designing chips is that you're so far removed from consumers that like you never really got to see the eyes of the whites of the consumer's eyes.
Yeah.
And there's like this one time where we were designing this chip that was supposed to have Wi-Fi and Bluetooth in it, and the person was sitting across the table from me drinking like a Starbucks coffee, and they're like, no one would pay 50 cents more for coexistence with Bluetooth and Wi-Fi. It's like too expensive. And the guy's got like a $3 Starbucks coffee in his hand. I'm just like,
and of course, like now everything is coexistent Bluetooth.
Yeah, they have all this sort of stuff in it. But you're so far removed from the consumers that like you just can't even like reason about the value of some of the features you're trying to put in this. It's really frustrating. You put all this effort in, and so I was like, okay, I want to like get. Like chip design is hardcore and interesting, it's cool, but like I want to get closer to like actually making features that people care about. Like I want to make decisions. So then I joined Chumby, and we had an opportunity to make hardware that actually consumers would buy. And I got to learn how to make the hardware, how to manufacture the hardware, and we had a chance to be like, okay, I really want to be open source, and so we like designed like this open source platform that was hackable, that is the Chumby.
Yeah. And then
and this was like a little miniature flash Linux computer that people could log into if they wanted to. Yes, SHN.
Yeah.
And it had Wi-Fi, and it had like audio.
Yep.
And it was basically meant to be like a little internet appliance.
Yeah, that's the idea. This is before like the iPhone and before a bunch of other things existed. And what we wanted was you want people to have a little internet portal next to their bed that could also double as an alarm clock, and then they could like see their Flickr feed or Twitter or Facebook, whatever it was. And then, but we didn't want to just restrict people to that. If they wanted to use it for something else, they could, and that was the whole open source aspect of it. And it was it was just basically a Linux computer on the inside. We actually added features specifically to enable people to hack. Like there's like hack ports and like a serial port that was labeled and a bunch of other bits. And we made a version so that the thing that's being shown now is the hacker.
This is kind of that's not what's in the Chumby, but it's the same hardware just sort of brought out.
That's right. Yeah, we took the same core and then we added explicitly a bunch of headers and stuff to allow people to extend. and hack on the exact same hardware that we used.
And I kind of
inside the
see
Chumby.
this as a predecessor to the Raspberry Pi. In my opinion, it's a kind of a, I mean, I can't prove that it was like this was specifically seen by Raspberry Pi team, but I'd be surprised if they didn't, because it is so clearly a predecessor. It's a Linux dev board that has had Wi-Fi, had USB ports, had a video port, headers, and it was designed for people to do. It had accelerometer even.
Yeah.
Remember, and what's interesting is we sold the Chumby hacker board, and a couple of the tutorials I read, I got some early tutorials on like doing GPIO and bit banging, and I remember being like, this is really interesting because you're in Linux, but then you run a shell command and like an LED turns on.
Yeah.
Which is like, you know, now of course this is not a big deal, but this was in
But
like
back in the day,
this was in like 2010 or 2009,
I think you're even earlier than that.
maybe 2008.
Yeah, around then.
And it was
I'd
just
say.
like super shocking. This is like, you know, we made a little cardboard thing and we put a Chumby in it, and you could play little video games.
Yeah.
And then of course like it turned into the Pi Girl, which we now.
Yeah.
It's almost exactly the same design. Like we like nothing's really changed. And
I love it when people do stuff with like, you know, like this. This is
yeah.
awesome.
But to me it's like this is just part of this evolution of like Linux computer as a hacking platform.
Right.
And I know that you're not the first Linux single board computer,
No.
but it was kind of the first one that was specifically targeted towards hardware experimentation hacking. And so like a lot of the example code that I wrote for the Chumby hacker board, I ended up just porting it to the Raspberry Pi. So
Yeah.
the first few tutorials we wrote are actually Chumby hacker board
cool.
tutorials.
Nice.
And
I
just
know
swap
that.
the images and just change
Awesome.
the pins.
Awesome.
So that was very neat.
Yeah, I mean, I really wanted to sort of create something that was more of a platform targeted to enable people to do that. That image that was just up now of the little Chumby like taped onto the wheels was an example of like, you know, it was the exact alarm clock form factor, but then there's a couple things broken out to a motor driver board, and you could like drive it around, and you could like, and the cool thing is because it was Linux, we then plug in a USB camera. And then stream that over Wi-Fi.
Yeah.
And so then we had like this little remote control car with a camera on it that we put together. It was at CCC actually, just hacked together in a couple of days. And we're just like driving this car around like, you know, like the Congress over Wi-Fi and stuff. And it was nice and moderate. Back in the day, that was like, oh my God.
It was pretty sweet.
Yeah.
It still is pretty sweet. I mean, it's always been, there had always been this really strong divide between the Linux software and then Linux as a hardware device.
Yeah.
Driver, so kind of interesting.
Yeah, now they have the Raspberry Pi. It's like, we could do it. But like this...
There was the BeagleBone before
Yeah, the
Raspberry
BeagleBone,
Pi
right,
too,
yeah,
right? So
yeah.
that was, like even that was
Yeah.
clearly inspired by the BeagleBone, which I think was inspired by the Chumby hacker board. And because I remember people talking about, you know, what is next after Arduino? And people were saying, you know,
Yeah.
Chumby hacker board, BeagleBone, and then of course Raspberry Pi came in and kind of combined the best of both worlds.
Interesting.
Okay, and then I have an embarrassing photo from 7 years ago when Adafruit was, I think, maybe like 4 or 5 of us, and we had just got our pick-and-place machine that could fit through the door.
Yeah.
And I think you stopped by, and I think we were selling the Chumby hacker.
And they see sticking my head in a freaking pick and place
You
machine.
love sticking your head in places.
Like I was just here looking at your new pick and place. He's like, oh my God, I love the motors and the actuators. It's so cool.
Sticking your head. Yeah, so
Yeah.
that one is a little mini, like one piece at a time. Now we have something that
Yeah.
does 20
Oh
pieces
my
at a
God.
time.
Look
But
how
it
you
got us
have
here.
grown.
Yeah. So we donated that pick and place to a hackerspace, and
That is
hopefully
so cool.
they'll manufacture. And I think not too long after that, because I'm trying to keep a nice timeline here, the NETV.
Yeah. That was sort of like it was actually an interesting transition out from the Chumby times. Actually, the NETV came about just after I moved to Singapore. We had started a field office out there, and we're trying to find a new way to bring Chumby to the world. And when I looked at the bill of materials, the most expensive thing was the LCD. And we're like, well, everyone's already got a big, huge, beautiful LCD in their home. It's called like a TV. And this is before they had those little stick Android like things you could stick in. And the whole idea was that like we could put a UI on top of your TV, on top of your content feed. And the thing that we realized is people didn't want to just look at Facebook only. They wanted to watch their TV and also know what was going on in their internet world at the same time.
Yeah.
And so we had this problem that we had to solve of like we needed to take live TV feeds and somehow blend them with content, except the problem is they're all encrypted with HTTP. But right around the time that we were thinking about this problem, someone had extracted the HTTP master key, which means technically I could find a way to encrypt my feeds to the same key that was used between the two devices. So we came with a device that would actually snoop the handshake between the sender and the receiver, extract the private keys of both sides, and then take the video feed they want to send and encrypt it to the same key that the sender was using, and then swap out the pixels at the same time. So what you saw in your monitor is a composite of the actual video feed, and then like say a Twitter bar across the bottom or like a Facebook bar across the bottom. And that was, I mean, I thought that was pretty cool at the time. This was sort of, because of the cost constraints, it was a little bit of a more demoware than product. Like it could only do 720p, and it had like kind of a stunted processor on it and all that sort of stuff. But we open sourced the whole thing and want to get it out there just so people could start using it.
Yeah.
And fast forward many years now. Can I go ahead and talk about the latest
Yeah,
stuff?
actually, I have just a question. So on the board, which is over there,
Yeah.
so there's a thing with an M on it. What is that?
Oh, that's a Marvell CPU.
Okay, so that's a CPU, and then to the left of that, there's a little module that's like a Wi-Fi thing.
Yeah, that's the Wi-Fi on the little.
White, green.
Yeah, that's the Wi-Fi module, and then the other side is the FPGA.
And then the FPGA is between the HDMI ports. So
Yeah,
that's
yeah.
actually what's doing that high speed.
Yeah. So it's almost like literally you can see the signal flow. There's an HDMI port
And
above and below the FPGA.
FPGA.
Right, and I made that the wires as short as possible, so I didn't have to deal with the signal integrity problems. Right, and then literally like the Marvell CPU like wedges LCD signal for the overlay into the FPGA, and then the Wi-Fi is on the other side of it. So it's almost like exactly matches the block diagram that you would draw.
Yeah.
So one question, Bunny, was this sort of like DECSS where one entity had the keys and it leaked and then everybody could get in, or is this a little different? Where how did the keys come about?
Let me see. I actually know the story of how the keys came about, but it's not public.
Okay. I don't want to know.
But basically, I think I can say this. Essentially, there's a weakness in HTCP where if you got a certain number of devices and extract different keys from each of them, you could do some linear algebra and extract the master key. And it turns out that someone figured out a way to do this, and the master key was then extracted. And then once you have the master key, the linear algebra, you could work on any subkey and then find what the device keys were and stuff like that.
Got it.
So
Okay, so
cool.
that was an NETV 1, and that came out, sorry, about what time?
2008-ish, 2010.
Yeah, I think
2010.
Yeah.
That's where I had the photo.
Yeah.
Okay, so that's NETV, and you also learned injection molding for this.
Yeah. That's right. That case, that case there was the first time I used SolidWorks and did soup to nuts, my own drawn. Usually I had a contract engineer who would do the stuff for me. This one here, I actually did entirely from scratch.
Looks
which
nice.
is thanks. I mean, it was interesting to learn and just go through the whole process and do the injection molding.
Okay, so now though you have bigger and better.
Well, there's another version that I'm working on. I think I have
V2. So let's check that out.
Kind of V2-ish stuff going on here.
How about I'll give you some space.
Yeah. I mean, it's we can show some bits and pieces here.
Okay. Can you get them underneath that?
Yeah. Sorry, I'm working on making some space here.
Here?
Well, put your thing here, and then I will.
Okay. We'll just put these all out here.
Okay.
Yeah.
Okay, there you go.
Yeah. So. Ooh.
Whoa. Sorry. Okay.
Yeah. And so the idea was that we want to make NETV, but sort of for a modern generation of things. Mm-hmm. And the idea is we decided to make it a PCI Express card so that you weren't bound to, the problem we had is that if you bound it to what we call the application processor, you had people who had very low-end requirements, like just doing a text overlay, and they're very cost-sensitive. And you had people who want to do 3D graphics, and they were not cost-sensitive. And then you had the problem of this mismatch between the market.
And then how do you tunnel the 3D through this low?
All this sort of stuff. And so by putting it in a PCI Express card, people could either pick a really low-end CPU or a high-end CPU, and we managed to disentangle the two from each other. So that helps a bit. In terms of that. And so this is, again, a similar architecture, 2 HDMI ports, an FPGA, PCI Express, and then importantly, this one here has a whole bunch of DRAM on it. And this one is actually also an interesting piece because we're trying to expand the capability this can do. So if you remember when I talked about the NETV, we're very careful to never decrypt anything because of a statute called the DMCA Section 1201 makes it a big liability to potentially manipulate the video streams without the explicit approval of the copyright holder. Even if you're just trying to do something as simple as like resizing and scaling, alpha blending, stuff like that, right? And so I'm working with the EFF right now to have a lawsuit to try and reform this so that we can actually do things like alpha blending, rescaling, and other things. So that, for example, you can do text overlays for closed caption for people who are deaf, or you can go ahead and view like a Twitter feed live over like a debate, a political debate or something. And you can pick how you want to do this, and resizing and alpha blending, a bunch of things that make it a lot more useful inherently, and a lot of features that people request, but we haven't been able to do because of the risks. And the frame buffer and the FPGA are picked so that we can sort of absorb these larger feature sets if we're successful in the case.
Okay. Do you want to talk about that?
So there was exceptions for things like ebooks, or I think like screen readers in the past for the DMCA.
Yeah.
So to help people who are vision impaired.
Yeah.
So it seems like this would go along with that because you could potentially add closed captioning or other things that could help people.
Yeah, there's a bunch of possibilities for how this can go. But ideally, I actually want to get, I want to be able to make this as broad as possible, because I feel like we had originally rights to do a lot of things with video. Like back in the 80s, we had the video toaster, and we had the ability to just like remix and blend video the way we wanted to. And now we have to do like this sort of like weird gray zone of like, I'm going to play video games, but my video game box outputs an encrypted feed, but I want to record it, so now I have to strip off like this encryption and like this.
Like, what's the point of even having? Yeah.
But it's dangerous to have that box that can strip off, because you could accidentally strip off something that's copyrighted, and like there's like all this weird stuff that happens now, and a lot of the reasons why these laws existed around the turn of the millennium, people were worried that like the big video companies would go away and that DVDs would get ripped and stuff. Well, I mean, guess what? Like, there's Netflix and all these things. They're doing fine, right? Like, it's like
the problem actually changed.
Yeah, and so I think like the law is kind of like a bit of a dinosaur now, and I think we should just revisit it and just like loosen up so we can do the things that we really need to do, and just get those traditional rights back. Like, I'm not looking to do anything crazy. This is just like bringing things back to the way it was. Yeah. And the world worked just fine. No one went out of business. So I think it should be. Anyways, we'll see. We'll see how it goes.
Okay, so if people want to follow it, it's the EFF lawsuit, DMCA Section 1201, research and technology restriction that violates the First Amendment. Is that it specifically? Okay, so they can follow along with EFF.
Yeah. It's just that article there is a press release and all that sort of stuff.
Okay.
What's interesting is we were chatting with. Public knowledge about, they were looking for DMCA exceptions for car hacking, and they kept saying like, well, if you have a farmer and then like they want to maybe like fix their tractor, and then right as they're like about to argue this, and from the Copyright Office, the Volkswagen Dieselgate hit. It was like the next month, and so they're like, they show up and they're just like, we're done. Like it was just like granted instantly.
We should grant it. Yeah.
You should grant it, and it was granted instantly because clearly we do need to have protection and to be able to reverse engineer and understand the firmware that's in our cars because of this like gigantic thing that's not even theoretical. It's like totally factual. So what's interesting is that while you may be fighting on this front, we don't know. There could be some other example that comes in and might make it easier for you.
True.
Like it's kind of like you never know, so you might as well keep fighting. Yeah. Because at first everyone was like, "Well, this like farmer tractor thing, like it's kind of it's so tenuous." But in the end, having all that preparation meant that when they did go in and they had this Volkswagen example, they were so set.
It's not just that, but again, this goes back to like when we talked about the hacking the Xbox thing, like that the thing that made the hacking the Xbox so risky was this statute, DMCA 1201. It says that because they encrypted the ROMs on the Xbox, and the fact that I had to, decrypt it to inspect things, potentially made me very liable, right? And this specter, the shadow that hangs over the whole scene, is pushed a whole generation of engineers away from breaking crypto could be really dangerous or whatever it is, and we should just avoid it. And then the thing is this car hacking is a good example. If you go ahead and you create this thing that allows people to shroud layers of secrecy on this and people can't inspect it, they can start hiding emissions like standard sort of cheats and stuff like that. So you don't know what else is behind there because of this very overbroad statute. And so part of the point of trying to rethink the 1201 is to say, look, having the ability to, for people to feel empowered and not risky, to look at their own things and to explore it and to understand it is very important as a safeguard in the future against a whole bunch of stuff, and also allows people to be more creative. A lot of people, for me, when I started hacking, no one was like, oh, it could be illegal. There wasn't even people weren't like, oh, that's scary.
Yeah.
The only thing is you avoided your warranty, right? Whatever.
Yeah.
I didn't care, right? But now, people are I show people and you're like, oh, aren't you gonna get sued for that? It's the first thing that comes out of their mouth. I'm like, why is that the first thing you're worried about? Aren't you worried about what's actually in this box, or the fact you can't
your
get
highest
into
risk
it?
is actually you're probably gonna burn your skin with your soldering iron.
Yeah, right.
That's
That's really the thing you should be worrying about. Is the soldering iron on the table, not getting. But the fact that becomes the first thing on people's minds shows how much of a chilling effect this has had on people just wanting to explore. And that to me is the biggest problem, is that there's a generation of engineers who just don't feel empowered to look at their own stuff.
Yeah, when we did the Connect bounty, and that was not even an encrypted video stream.
Mm-hmm.
People were like, oh my god, it's illegal.
Oh, it's crazy! Yeah, that's the first thing I say.
First off, it's not even encrypted.
Yeah.
And second, I bought this thing.
Yeah.
Once I buy it, I should be able to do whatever the hell I want with it.
Shouldn't it be the case? I mean, and I wish we had a time that was when it was simple. Oh yeah, of course you can fix it. You can do what you want with it. I mean, back in the day when you had farming equipment, a tractor, if it broke, you just fixed it. You didn't is it going to
We used to buy an Apple II and it would come with a schematic.
Yeah, and you would
is your disk drive acting odd? Well, okay, open it up, find the potentiometer, and twist it to the right. Does it work better now?
Yeah,
twist it to the left.
Yeah. And I think that's how it should be. I mean, anyways.
One of the things that we thought we'd have to fight was some of the large 3D printing companies, Stratasys included, wanted to make it so you couldn't use other filaments and other 3D printers. And if you reverse engineered the RFID tag, you couldn't use other filaments. Looks like that's not going to work out, and not many people want it. And the companies that are trying to do that, consumers aren't buying those things.
Right.
So the market helped decide.
Yeah.
But that was one of the things that came up, and we're like, that's a terrible world to live in, where you can't use your own different unique filaments. You can't use experimental ones, and you can only use the ones that the printer companies want.
Right.
Just I think there was a few physical, the old printers, inkjets.
Yeah, these are some of the unintended consequences.
No, 1201 is this is really getting a little excessive.
Lexmark or something like that.
They did something. There's a whole slew. Anyways,
all right.
I could let's not go off too much in the weeds.
But wait, there's more. So the other thing,
there's more.
Yeah. So this came up in the news not too long ago. You were hanging out with Snowden or something. What's going on here?
What is this thing?
So that's called the introspection engine. And basically, there came about sort of a question was asked to me. A mutual contact between me and Ed Snowden had introduced us, and he had a problem where he wanted to protect reporters who are in dangerous situations, like in Syria and North Korea, all those kinds of places, where they had state-level entities who would benefit from being able to eliminate them from the territory. I mean, with artillery, not not just eliminate, but kill, right? And the question was kind of posed well, what can you do to protect against that level of an entity? They have infinite resources. They'll spend $1 million to to exploit a phone and figure out where a person is. And so I thought about it, and it's a principle. I think it's sort of like the Death Star principle. Any system that's sufficiently complicated is going to have a weakness so subtle that no one can
Right,
find it.
because the surface area is just so big.
Right, yeah, the attack surface is huge. Even if you have the open source and everything, you can like look into it. Yeah, like people have said, like, oh, let's build an open source phone. Like this will like solve the security problem. Like you don't. There's millions of lines of code in this thing. You're never going to find all of the exploits in this phone. It's like that doesn't really. I mean, you need to have the open source, but if you really want to be secure against like a state level entity, you have to have something that you can actually independently inspect all the pieces and understand what's going on. And so what we decided was like, okay, let's build a simple thing that we can understand, and then hook it to the hardware points in the phone that are connected to the radios. And we can monitor if those radios turn on or transmit and stuff like that. And if those start transmitting when we don't want them to, then we know the phone's definitely compromised. And this is a method we call direct introspection. And so we built this thing called the introspection engine, which accomplishes that. I have like actually the most recent
It reminds me
stuff.
a little bit of like, there once in a while you hear stories about like, well, there's an LED that's supposed to turn on when your webcam
Right.
is on, but like sometimes the firmware gets hacked on the
Right,
the camera.
if the LED is in the
And
firmware,
so, like,
right?
So like I'm always like, well, why the fuck did they put the LED on the chip select line?
Yeah.
And like, so there's no
Or the
way
power
to,
line,
or
yeah, to the
power
LED,
line.
right,
But no, they
exactly.
actually make it so it's like
Yeah.
optional. Okay, so what do you have
so,
here?
So a bit of stuff here. So we have, we decided, can we zoom out a little bit?
Yeah, you can bring this up,
Bring this up. All right.
and then can you hit the AF button right behind there?
Okay. Okay, cool. So we decided to work with the iPhone because that's something that like one of the important things we want to make sure the technology is very usable. So yeah, we could have maybe gotten to something more bespoke, but a lot of reporters want to use iPhones. And I looked around on the inside of it and found a bunch of test points on the inside that are related to the radio function, like hardware points that must be activated for the radio to work. Like
So the radio is not actually integrated into the main chip. They're separate chips.
there's
for
a
radio.
there's a base. It's like actually the iPhone has like it's crazy in terms of the amount of stuff. But there's like for example, the antenna on the iPhone. This little thing here, right, has to do like 2.5 Wi-Fi, GPS, and several bands of 4G, like 4 bands of 4G, 3G, 2G, from one antenna. Right, and so they have like this huge like RF multiplexer in front of it and antenna calibration subsystem that has to be turned on, and it has like a bunch of independent signals that are completely separate from the baseband, completely separate from the application processor. And so we monitor those signals because in order for you to even send a packet, you have to turn on this whole engine behind it.
And because the antenna, there's so much like physical difference between antenna, they're probably individually tuned, so there always is going to be.
But they're actively calibrated.
Yeah, so it has to be a separate process.
Yeah. It's super crazy. There's like actually this little chip here at the time. It's hard to see. See
Oh yeah, that little.
see how there's a little
chip
screw
scale?
that goes into this thing, which is the antenna.
Yeah.
That's like an active. It's like a tunable capacitor thing that can tune like the resonant frequency of the antenna actively.
That's cool.
To optimize like the performance of it. Anyways, so that's one of the things that's going on inside of it. And so we built this flex PCB that we found if you remove the shields and stuff, you'd see that this actually solders into some points and then brings it out to a connector here on the side. So now you can close up your phone and you don't have to see all the ugly wiring on the inside. Let me just.
You must be like a super pro at opening and closing phones then.
I had to learn a lot about. I actually went to the Chinese markets and bought a bunch of motherboards that like kind of scrap ones and practice removing the chips and all that sort of stuff. And finally came up with a set of techniques that are actually pretty repeatable for doing. We want to document how to do it and all this sort of stuff. And so from this connector here, that then plugs into this system here, which is the introspection engine itself. This is actually a complete bodge prototype. I can actually power it on. I think. Do you have a USB mini USB thing I can use to?
There's a bunch of USB cables.
Okay.
You
Oh,
just
perfect.
pull on the cables until you find one
Perfect.
that's the connection to.
Yeah.
Do you need a micro USB?
Yeah, micro USB. What happens is I have this.
Pull on the long wire that's coming out from the top.
This one here.
Yeah, just yank on it. Ding, 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 ding. And then
Okay. Yeah.
just make sure that this is on
Okay.
or off, whichever.
I should be able to boot this. The firmware in this is like hot off the press, so it's like
Ooh.
it's very like. Yeah, there you go.
Okay, I'm gonna put it under to the.
So you can see here It has like a little OLED display on
Oh,
the
you just
inside.
mounted on the inside. That's funny.
Yeah, and it has like a UI that's working at the moment. And of course, it says like all the statuses are bad because there's no phone attached to it. But this is the idea is it's a little case that you slot the phone into. And you can see I have 2 SIM cards now. So I actually found a way to be able to have 2 SIM cards, and you can swap between them.
Oh, so the SIM lines come out.
The SIM lines come out too, and so it gives you a nice little feature where you can I want to use one SIM card, another SIM card. You hit a button and it swaps the SIM cards on you live. And so there's a bunch of bodges here because we're still developing the firmware and stuff. And then
Yeah, no pressure. I wasn't expecting a live demo at all.
well, we'll see if this might be a bad idea to put this all together, but the idea is that this becomes a this should slot right into here. And do you have like a screwdriver or something you can use?
Yeah.
We still have one from your laptop kit. You want one of these?
I think, or a
have
pair
a
of
set.
tweezers or something like
What do
this.
you need?
Oh, yeah. I just need to be able to flip over a flex connector very carefully
No pressure.
on the inside here. Well, we can always edit out in post, right?
Are you kidding? This is what people are paying for.
Oh, Jesus. Let's see if I can get this. It's a little tricky because the case actually I'm using for this is
Yeah, what is that?
it's a repurposed case from what is an off-the-shelf device. And the idea is that someone sold like a phone in a case that you could use, like a feature phone that actually was in here.
Yeah.
And it had like a spot for a screen and like back, and that was perfect basically. And we're like, okay, well let's go ahead and get that and then like hack it and fit all the stuff on the inside. Okay, there we go. And so this can now power on. This is no SIM card installed, but I should be able to, for example, tell it to switch SIM cards. Oh, that's no arm.
I have a question for when you did this. Did you get those like iPhone schematics that you can pick up on the Chinese market? Yeah, that's so cool. I love that. You can get anything.
Yeah.
They like have like the full.
They
like,
have all
pinouts,
the
board
things.
layouts, all the
All
connections.
the things. Let me see. No, I think I might not have gotten the cable on quite right. Let me try it. Maybe easier to do it with
Do
it.
you want like tweezers and?
Okay. It's hard to do without a good pair of tweezers.
Do you, what kind of
No, I got it. We'll just do it like flipped off to the side here.
You are in like an electronics factory. This is like the
This
one.
is true. This
This
is
is the one time you actually have a shot.
There we go.
Want to make 1,000 of these later?
We may need to do something like that someday. And so hopefully it will now connect through and recognize the SIM card. Give it a little while to think about it. But anyways, the general idea here is that you can see this cable here
Yeah, that's the cable that came out.
comes out of the phone, goes into here.
What's that processor in there?
So this is a Lattice ICE 40 FPGA, and the cool thing about it is that it has a full open source stack. So one of the principles behind this is we want to build something that was fully inspectable and you could understand. And so I laid out the board where most of the components are on the top side. So if you want to check against Evil Mate or something, you can just like look and see is everything basically there. There's a full open source FPGA, so you can know what the code's on the inside. There's a little Kineta CPU here, which you can also look at all the code on the inside, runs Chibi OS, and a pair of SIM cards. And that's basically it. So the signals coming out of here, the radio antenna signals coming out of here, or the radio sort of configuration signals come into here, a bunch of UART lines, and the SIM card lines. And the FPGA will do some processing to see if things are being turned on or not, sends an alarm, and then this guy basically translates to the UI that you see on the screen on the other side of the device.
Just because you need
there you
an
go, yeah.
FPGA that's fast enough to be able to see the pulses.
That's right. Yeah, they use a bunch of like sort of custom buses on the inside, and they're not standard. So I couldn't just hook them up to an MCU. I had to have some piece of hardware that could handle it all. And so if I go ahead and let me see if I can tell it to switch SIM cards. There we go. I just told it to switch SIM cards. It goes and says no SIM card installed, but It
Then it will like, hey.
But now I swap to a new SIM card. It says no service because we're using some Singapore SIM cards that don't work in New York. But so it just swapped the SIM cards from the other side. Anyways, that's sort of, and then part of the thing is this has a bunch of monitors on the inside, which will tell you like how long.
So it says.
Right now, it just says all the statuses are bad
Okay.
because it's got some.
You're still working on it.
Yes. Well, yeah. I haven't told it that it's there and
Okay.
calibrated. There's a bunch of other things that we have to do. But like I said, this firmware
You're
is
getting
like
there.
currently in development.
No,
Right?
no, no,
There's a lot of like you can see like off here is like the debug headers on the side and all that sort of stuff.
Good times.
We're doing all that nonsense.
Well, this is really neat. So it's like you're basically doing, hardware inspection that you're basically going around the firmware because you're even a couple months ago you hear about SMS malware for iPhones that will make it roots it so hard that it will say your GPS is off, but the GPS
right.
is really
Yeah. That's right. And so the idea is that this
you
gets,
actually have like it's true.
Yeah.
Like it's actually happened.
Yeah. And so this gets around all that because it actually, for your GPS to be turned on, there's a particular signal that will always be present at the hardware level. So even if your phone's completely rooted and it's lying to you about everything, this processor here is in an independent execution domain that can't be rooted, can't firmware update to it, wherever it is. And this FPGA is monitoring those signals, and so it'll say like, hey, like your GPS is actually on, and then the UI would show that to you, and then that's the overall idea. And you can see this is the big red wire for the battery because I haven't got the battery management code working and all that sort
That's
of
all
stuff.
good.
That's how I turn it off.
So how many revisions has this gone through so far?
This is my first version.
Okay.
Yeah, so this is like really, really, really like hot off the press stuff. Like not even really like fully
So
vetted.
for the paper that you wrote, you just used an oscilloscope, and like you're like, well.
Yeah, so the paper when we did the paper, if you go back to that, do you have that illustration there that we had? That one there. That is like that's a rendering.
No, yeah.
That's complete bodge, right? And that was an example of where we want to get the thing at the end of the day. And we went through with an oscilloscope, identified a bunch of signals, and said this should be totally feasible. And so essentially, what the next step is to like just prove it, like build the hardware that monitors all these things, shows it can be done, kind of put it all together, and then open source it, and put it out there and be like, okay, look, if you want to build one of these, you can build one, and here's the firmware, and here's how to do it. And that's basically where I want to bring it to at the end of the day. That's kind of a line where I stop. I'm not going to get into like the distribution and manufacturing and pushing out of all this sort of stuff. Like someone else can pick up that sort of stuff. I just want to develop the technology behind it. And so now you can see that I would say we're like almost halfway there, right? I mean, we've got a first version. It's booting the OS. It's monitoring the signals. It's actually pretty interesting to see what the conversations are in the baseband and like off the UARTs and all that sort of stuff. We're starting to, getting data. So everything looks good. But firmware, like, funny thing is like for these projects, like I would say like I spend 60% of my time writing the firmware. The hardware is like the easy part.
Yeah, I know.
Right?
You're like,
yeah. It's like all the code and all the sort of stuff that goes behind it, and like this whole UI subsystem that you saw on the other side. Like I had to write an eventing system. I had to do a touch screen interface. I had to use UGFX to render all the things. I had to figure out where the strings go. Like there's like all these decisions to make. Whereas on the hardware, it's like I want to monitor these signals. All right, easy, done.
Solder to it. The hardest part is like you solder to it. Now you're.
Yeah, actually, there was a little bit of challenge because like this particular thing here where I had to build this flex PCB. I actually have like examples of it. This was fun.
This is a neat idea because you always hear about people installing applications and the apps are phoning home, but you never really know. And then there's another layer, which is hardware.
Let's look at this overhead.
And you never know if your hardware is doing that.
Yeah.
So
what a crazy flex PCB.
So I had to design this flex PCB. So this is the flex PCB that is actually installed inside the phone. You can see there. Actually, this one.
And so like it's just got all the little signals.
Yeah. This one got a little munged.
With little test points at the end.
Yeah. So the idea here is that there's a little wire that runs along here and it splits out, and there's little test points you can solder down to on the board. And so I had to actually take.
What's with the serpentines? Why do you got?
So the idea is like there's a little tolerance always.
Oh.
And so the idea is I want to be able to stretch the wires without having to like
rip them.
to rip them and stuff like that. So I use the serpentines to go ahead and absorb the tolerance.
Okay.
And because I have to wrap around the side of the phone, and you never know, it's hard to know how thick it's going to be.
Mm-hmm.
And so I had to actually get the circuit board, put it in a high resolution scanner, mark it where the test points are, turn them into a DXF file 1-to-1, put them into Altium, flip it over, create like this flex PCB file, and then get all the test points to line up. But this thing makes the job of soldering the test points on a lot easier.
Yeah, this is like really nice.
Yeah, and so basically it's all there. Once you solder in the core sort of reference points on the SIM card, all the other wires sort of line up at the right spot, and you can just like solder drops on the test points.
So there's about 7 or 8 points.
Yeah. So these here are for the baseband, SPMI. I think this is the Bluetooth. This Wi-Fi and a Wi-Fi reset signal, the SIM cards, GPS, and baseband UART somewhere on here. Those all get broken out into this header here, which then gets fed into the circuit board that monitors everything.
Cool.
So it's coming along. It's coming along.
Okay.
A lot of work, but it's coming along.
All right. Well, speaking of a lot of work, we're one of your customers. We bought one of these.
Woohoo!
We bought a laptop. I think.
So we're fast forwarding to the future, and this is like 2 years ago. 1 year ago.
Yeah.
So I'm going to play a little video that you did for Crowd Supply. Cool. I think that explains it best because you had to make a video to sell it.
Yeah.
So here we go.
Roll the clip.
When I first started getting into hardware, something that really enabled me was the fact that I had schematics and source code to my Apple II. And I'm really excited to build a full open source laptop from the ground up with my own 2 hands. Everything from the circuit boards to the chassis to the operating system level. I'm a big fan of open hardware. A few years ago, if someone presented you a scenario where perhaps you're worried about your hardware being modified as it's being shipped to you, they would say you're crazy, you should have a tinfoil hat. Turns out that you're not that crazy. There's actually evidence lately that does happen.
The latest revelations that have come out from Edward Snowden talk about a secret workshop that would install chips into computers.
If you can't hack it, you don't own it. So the device has basically the kitchen sink in terms of slots and ports. It's got 2 Ethernet jacks, SD card, micro SD, micro USB even, a couple USB ports, serial, a high-speed expansion port for the FPGA, PCI Express, SATA, a custom power connector on the inside for expansion to a battery board, pretty much everything that a hacker would like to use. We're excited to offer you 4 models of the Novena platform. There's going to be a bare board for people who just want to have the hardware and do what they want with it themselves. There's going to be what we call the desktop version, which is a bare board in a case with an LCD, meant to be tethered into the wall. There's going to be a laptop version, which is the desktop version plus a battery and an SSD, so you can use it on the go. And there's also going to be an heirloom version, which is a beautiful handcrafted case. We invited a guest artist to go ahead and build it, Kurt Mottweiler. We gave him the open plans, and he came up with his interpretation of what he thinks a beautiful laptop case should be, and I think it's going to be outstanding. The hardware is ready for production, and if you like what we're doing and you want to see more open hardware tools, please back us on Crowd Supply and spread the word. If you back us now, you receive a Novena at these special campaign prices. Thanks and happy hacking.
What was that secret message at the end?
Oh, it was like a little Easter egg they buried in there.
Okay.
Part of
You get my
So we have one
MD5
of
decoding
these.
going on or something.
Yeah, and thank you for signing it.
Okay.
So, this is, so maybe put it under the overhead and talk about what's going on inside here a little
Move
bit.
all this stuff out of the way.
Yeah.
You know?
Try not
So
to
why'd you make a laptop?
Well,
Put the screwdriver in the thing. Yeah.
why not?
Exactly.
I mean, like ever since you know, I was a kid, I'm like, I want to build my own computer, right? And what does it mean to build your computer? I don't know. There's like, it could be all the way down to the silicon, could be all the way down. And so I was like, okay, well, practically speaking, maybe I could like design a circuit board and a case and all that sort of stuff, and I wanted to be exactly what I wanted. And this was literally came out of this right after Chumby went under, and Sean, who you saw in the video, Zobs, and I were sort of in Singapore drinking beers, and we were just like, all right, what
Now
next?
what?
And we're like, well, we just want to build our own laptop. Why not, right? And so we just started like...
Some pretty good beer you had.
And so we started like playing around and looked at sort of what was available in CPUs and what we could get and what we could afford and what was practical and blah blah blah. And it was a bit of an experiment. I mean, it was a bit of a risk. We were never sure if we could complete it, but we did.
And here it is.
Here it is, right? It was a lot of work, but it was also very rewarding. I learned a ton doing this. I mean, it was just like there's so many like interfaces and standards and bits and pieces, like what's used for the gigabit Ethernet, what's like the signaling standard on the inside, PCI Express, DDR3, how do I, what are the impedance controls for the different high-speed buses, and then like the battery board itself. I had never done like a battery subsystem that had to, supply that level of power and this level of reliability and all this kind of stuff, and then we had to learn sort of embedded display port to get the LCD going, LCD selection, supply chain, for the whole case and all. Like, there's a lot of things we had to learn to make this happen.
Not much more complicated than a laptop.
It was, and like these hinges that we use on here, they're custom jobs that we got in China.
Mm-hmm.
This crazy cable we had to do. Each of these little blue wires is actually a little micro coax.
Oh, wow.
That we had to get custom made for this project. Like, there's a lot of like bits and pieces that we just had to learn and get together. And I'm really happy that there was a bunch of people out there who were interested enough to help us fund it through the crowd supply platform.
How many people eventually got?
A few hundred. I think it was like 500.
Wow,
was
that's a lot.
Yeah, was the total run. I mean, it's tiny for a laptop. I mean,
But it's a lot for a single person.
Yeah, it's a lot for a single project. But like, most laptops, that would be a total failure if HP sold 500 or something, right?
I don't know. I had a few Sony Vios where I know they only sold a couple hundred.
Really? Okay.
Yeah.
And I mean, we opened injection mold tooling and used it 500 times. I mean, that's like kind of crazy to do that. But and part of the cool part of one of the things I've been learning out in Asia is how to get stuff like that done economically and sort of get these things built. So it was a lot of interesting stuff. Like, this we also did this gas piston hinge here. I don't know if you this
That's
thing
cute.
here. So the idea is like it was not only an open source laptop, it was a self-opening laptop. And we had to get this particular part was a bit of a pain to source, and we also need to do reliability testing on the hinge. And I hate to say this, but like there's a guy who had to like open and close the case 1,000 times to make sure it could do that, and we had to do that multiple times because it didn't work the first time through, and we had to like revise the design. It was actually pretty late in production. We had a bunch of stuff actually already CNC'd out in aluminum and found it wasn't durable enough, and we had to move to steel, and we had to scrap all the aluminum parts and blah blah. Well, it's fine, whatever. Like, this is all.
That's for the process.
This is a day in the life of manufacturing.
Yeah.
Right? This is what I deal with.
Is this the only open source laptop, like as close as possible?
There's a bunch of ones that are open source to different levels. This is, as far as I know, the only one where you can get the schematics, and the case design full up open source.
Yeah, like the Neo something, the little palm top.
Yeah.
But they didn't really release, I think.
There's a bunch of ones that are coming out, and actually, really kind of like, it's funny, like, Nadia Peak?
Yeah.
Yeah, she we were on the stage once, and she like looked at me in the eyes and was like, "You're actually not like a hacker. You're an investigative journalist, right? Like you did this thing not to sell laptops, but just to show that it could be done, right?"
Yeah.
And I was like, you know what? Sure, I think you're right. Like, I mean, I'm willing to go with that, because like, I didn't build this laptop to create a business. I built the laptop because I wanted to build a laptop and see if it could be done, right? And one of the things you'll notice, actually, if you go to crowd supply, you want to buy one, you actually can't buy one now because it would have been way too expensive to like. We raised that amount of money, right? But if you think about it, if we want to build another 500 to sell later on, we would need close to that amount of money. But we didn't raise that for the future. We raised enough to to sell it to you today.
No, you basically,
Right.
I mean, you didn't make any money on this.
Yeah, and it's like, so
you basically like covered your costs.
right, and so am I supposed to now open my wallet or take out a loan for hundreds of thousands of dollars to like fill a supply chain so people could buy them? Like, no, I wasn't going to raise money and stuff like that. This, like, we did it, and we're going to support the motherboard, which is what we promised, right, for 5 years, and people can buy those all they want. But the case and all that sort of stuff, and then the nice thing about it is that after this came out, there's now a bunch of other projects that are coming up trying to do open source laptops. And I'm super excited that other people are now picking up that thing and pushing forward, and they're getting better and better. Right?
like the first
You just had to show it was possible.
Yeah.
You just had to show it was possible.
Yeah, show
like
it's possible.
Like you were
Right,
saying
yeah.
before, if it's only a small group of people that can do this magical technology thing, we'll never try.
It was like, oh, you had to be a big company to do it. Like, it's impossible to do. It's like, no, actually, like, you can be like two kids or whatever is, drinking beer, figuring out we want to build a laptop.
Yeah,
And
you
you can do that. I mean,
And
it
once
just
you
takes
show it,
time and effort.
Yeah, I definitely think once people show it something is possible, then people no longer have that like unsureness of whether
Right.
They get over that, and then they're just like, well, what can I do with this? They take it to the
Right.
next level.
And some of the stuff I've seen, I don't know how much I can talk about, but some people have like showed me some of the things they're doing for open source laptops. Like the stuff that's coming down the pipe looks really good. Like
Great.
Like really conventional quality looking laptops. They're full open source, and yeah, I'm very pleased to see that
There
people
was the
are working on these.
there was the freedom defined laptop, right? Wasn't there one?
There's a bunch of them. There's like Librem and some. I don't remember all the projects that are public or private or whatever it is. But
This one was sold and it was available, and it was like the only FSF approved laptop.
right, yeah. But I think that one, the hardware itself you couldn't
wasn't.
But
Yeah.
but it was like the whole idea was that the BIOS
The BIOS was
and the drivers, there's no blobs required.
Yeah.
So that's a very sort of like FSF angle
Yeah.
on what openness
Which is different, right? They
Right.
were just saying at this level and above, it's
Right,
open. You're
right.
like, no, I want the level of openness to be way lower.
Yeah, and we all have our own angles, and that's fine. Everyone can do what they want to do. But I like pushing on the hardware side. I really
It just
want.
means someone can go and combine both now.
Yeah, that's right.
See, there's
And
so many
this-
opportunities.
Yeah, and I'm really excited that actually there's like a company, Sci-Fi, who's coming out with like an open RTL CPU, right? So finally we can get like a CPU. They can go to the GitHub repo
Yeah.
and like check out all the code on the inside. And I'm like, okay, now we're cooking with gas, right?
Yeah.
This is getting me jazzed
Well, it's
up.
interesting. It's like the tools are getting good enough and powerful enough that people can do that,
Yeah.
right? Because
Yeah.
it is getting to the point where you can now. Used to be, if you wanted to do like hardware CAD, there was no such thing as an open or free software. Like there was
Right.
no such thing, and now there is. So
Yeah.
it actually is opening up to
Yes.
more
Yeah.
weird possibilities.
It's great. I mean, and it's just one of the nice. I mean, one of the things about open source is like you just have to wait a while, and good things start coming out of it. Like originally there was like in office productivity there was like Word and Excel.
Lotus Notes.
And Lotus Notes, and you had to buy these closed source versions. But now you have like LibreOffice, and it's
Right.
really good and it's very usable. It just takes a few years longer. But the thing is, like, word processing software only needs so many features.
Right.
Like around 2003, it really got all the features it needed.
We're done.
And for the last 10 years, they've just been trying to find ways to monetize like a market, and really like, and then eventually open source software just adds enough features, and they get feature parity and start pressing past it. And I think that the challenge has historically been that Moore's law has been moving so fast that open source hardware efforts couldn't really catch up.
Mm-hmm.
But now that Moore's law is sort of leveling out, there's a chance for like tinkers and hackers like us to sort of like catch up and say, look, we can build something of the same quality that you can buy out of like the big OEMs, and it's totally usable. And I'm really excited for this.
Really?
One of the other things that I like is it seems like you always show your work. I feel like we always have a similar path. Like you show that something's possible to build. Adafruit shows it's possible to manufacture. Regular humans can still do it. But then you came out with this book, and we stocked this in our store. You show like, okay, this is how you would do a supply chain.
And this is all the stuff I'm assuming you learned by doing the laptop, because a lot of these parts, a lot of things in there were like,
So what is this
clearly
book?
you went in and you were like
Yeah.
specking parts.
Yeah. So I mean, one of the great things is about being in Asia is I'm close to the electronics markets in Shenzhen, and it's a huge resource, and it's overwhelming, and and you need to know.
How often do you go to Shenzhen?
I go once a month at least.
Wow.
Typically.
Do you have like a 10 times free card or something? Like, do you have a little like punch card thing? Like how you, that's really often.
Yeah, well, I mean, Singapore is like a 3-hour flight away. It's like going from here to Austin, Texas, or something like that. And it's a relatively reasonable price flight, and I have like I've all
And you
like,
save so much time by going there. You're like,
oh, that is totally the reason why you go in person. Is like just trying to like go on the phone or email and describe to someone what you want is like takes a really, really long time. But you go to the market and you see like all the switches in front of you, and like you just like grab them and touch them and see how they feel, and then you see switches that you didn't know existed, and like, oh, actually that one's even better, and like, and you start asking questions, and then all of a sudden like what would have taken you like 4 rounds in FedEx and 20 emails in 2 weeks is done in like half an hour.
Yeah.
Right. And so that combination of just spontaneous discovery and the efficiency of just being there and working with them is the reason why I go about once a month. Of course, the internet sucks there, and there's a bunch of other problems of being in China.
So you only go once a month.
So I get out of there. I live in Singapore where the internet's free and open, and like and I can get all my other work done, and I go there once a month to deal with all of the supply chain stuff. And but it's so close that if I have to go more often, it's not a problem. It's like a weekend trip or a couple days or whatever it is. Yeah, I've actually done trips where I go in the morning, come back in the
I remember
evening.
you told me once, like you went to Shenzhen. This was like a long time ago. You went there and you got like bags of pogo pins, and you said pogo pins were in America if you buy them just give you like $1.50 each.
Yeah.
But in China they're like 10 cents a piece.
Yeah.
And they're exactly the same thing.
Yeah,
I mean
yeah.
they're disposable anyways.
Yeah.
So you said like you bought back like
Yeah.
and you're like I paid for my trip with the.
Oh yeah, with the pogo pins. Yeah, just with this bag here, of
This
pogo pins.
gigantic bag that you
Yeah.
had, and you're like,
Yeah,
I
yeah.
bought thousands of them. I'm set for life.
Yeah. It's like
Pogo pins that come out of
I
yours.
still have this box of pogo pins on my desk. Or like, this is the tester box, and I'm never going to run out of pogo pins.
I know, because nothing's worse than running out of pogo
Yeah,
pins.
I had, and I also like had this problem with 0.1-inch headers. I keep on running out of them, and DigiKey they're ridiculously expensive. I was like, fine, I'm going to just buy a bag of
like
1,000 headers.
Box.
And I go to like some vendor and say, I want 1,000 of those headers. How much is it going to be? $4. All right, fine, done. I never have to worry about headers again.
Okay, so everything you've learned by going to these trips once a month, you've written down.
Well, a lot of the things. It's hard. Some of them are hard to learn. Some of them are hard to write down. But
Can you actually talk about the cover first? Because this is a really cool story.
oh yeah, so the cover here. What's the best way to show it? Is this which way is right? It's right side.
It's right side,
That's
right
right side
side.
for the
Yeah.
okay. So the cover here is actually designed in Altium. It's actually based upon footprints of parts that I have in my library, and this is like these are differential pairs that are matched, and then like wiggle, and so. One of the things I've had to sort of do a lot of in China is printing, because I have to do retail boxes and books and manuals and stuff like that. And I like, of course, I always like to get in the factory and stick my head in machines. And I went to this factory and they had this whole assembly line in the back for doing gold foil embossing. They do like Bibles and like fancy planners and Buddha books and all that sort of stuff. And I was like, how much is that? Like, can we do this for my thing? I was like, oh yeah, sure, there's no problem. We can do this. I was like, oh okay. Well, I'm gonna do like a gold foil inlay for this book I'm doing. And I was kind of struggling with like what the design should be, and I want to do something with like a filigree that like looked really beautiful, but I'm not a very skilled artist in doing that. And so I went to Altium. I was like, well, what does the fill function look like? And so this is actually just like a ground fill.
Yeah, it's like a
from
hatch
Altium.
fill, right?
Yeah, it's a hatch fill, and I just put some circuit board parts down and all that sort of stuff. And so this is actually designed in Altium and then exported to Illustrator, and then eventually turned into.
Nice fiducials in the
Yeah,
corner.
I did the circuit board fiducials.
Yeah, so you
here.
know where you are.
Yeah, so I know where you are and
Okay.
all that sort of stuff. And then anyway, so
This is the essential guide to electronics in Shenzhen.
that's right.
Okay.
Yeah,
By you.
by me.
Okay, so what's in this book?
And so the core of the book is a bunch of like translations. So if you want to go and say, I want to buy some resistors, and I want the cheapest one, you can put here, and say 最便宜, right? And then or you don't have to even pronounce it. It's like in Chinese.
You just point to it.
Point to it.
I'm sure they're used to people who don't know Chinese going there.
They are, but then there's things like technical terms, like you want metal film or ceramic or carbon film.
But like it's my thing. So like I once went to France. I just went to Paris to just like see it when I was in college, and I needed a hairbrush because my hairbrush got broken. but I didn't know the word for hairbrush. But I went into like a pharmacy right with the green square, and I was just like, well, I need a.
Oh yeah, and you like do the whole like
and they're like,
charades game, yeah,
and
yeah,
like,
yeah.
Because you're going there, they're not going to be like, oh, like you want like a soldering iron. Like if you're going to the place, you see the resistors. You can just point to it, and they're going to know.
That's right.
That you probably want resistors.
Yeah,
So you just need a little bit of help.
Yeah,
you don't need to use the whole word.
Right. Yeah.
You don't need the whole sentence.
Correct.
You say metal film, they're going to know that you don't need tinfoil.
Yeah, that's right. That's right. Exactly. Yeah, this helps you get into the details. So you go to the resistor shop because they have shops that are just so.
And
resistors.
you know it's a resistor shop.
Yeah, it's definitely a resistor shop. There's nothing but resistors in it, and and those people are specialties in their trade, and then you just show them the different pieces, and so there's different like capacitors and
it
LEDs.
seems like to me, whenever I've talked to salespeople from Chinese
Inductors.
companies, they're actually and this is something I've tried to explain because I was reviewing this, and it's kind of weird to explain to people. But first off, and a lot of people are like, oh, I bought this thing from China, I got ripped off, and I'm like, no, you didn't get ripped off. You actually just didn't properly explain what you wanted.
Right. Yeah.
And it's actually like a really delicate thing to explain. It's like nobody's like ripping you off, but you have to be very specific about the minimal requirements you need, because if you don't specify those minimal requirements, you're not going to get them. There's no assumptions.
Right.
And once people get through that, I think they have a much better time.
Yeah. I would say like almost 99% of the time, people are really trying to do the right thing. There is like a percentage of people who do.
Yeah, there's a couple things you gotta watch for.
But
cables get shorter.
Yeah.
I've noticed. Right, the cables they start at like 3.3 feet, then they go to like 3 feet.
Yeah, and the copper gets a little thinner
Have
on the
you ever
inside.
heard the Chinese inches thing?
No.
No, it was just like we ordered some wire, and it was marked 24 gauge, but when we stripped it, because we do that, it's like that's not 24 gauge, it's 30 gauge, and they're like, oh, it's Chinese gauge, and I'm like, no, it isn't. And like it never happened again, but like.
Oh, that's funny.
But that happens. It happens once in a while.
Yeah, I could see it being like, oh, it's not 2.54, it's 2.5, right?
Yeah,
like,
and then eventually it just gets shorter and shorter. It's like, that was from connector to connector. And
Yeah. There's a bunch of like little.
But if you specify exactly the requirements, I've found that like as long as you are very clear about the requirements, it actually it doesn't happen as much. And also, if we do get something and it's discrepant, they will replace it.
Right, yeah, no, that's true. I mean, one thing you get really good at is documentation. Like, it's no longer like I think we're a little bit, you can get a little bit spoiled being cavalier, saying like I need a resistor you buy from DigiKey, and like there's like this set of things that we all expect that we get from it.
Right.
But when you're sort of like exposed to places that could build anything, it's not just what's in DigiKey, but you have like the full spectrum of all the parameters you could build from the cheapest to the nicest. And you say I want this, and you assume that they know what you're talking about. Like it's hard to know. You really do need like a full you're like, why am I here like speccing like parts per million of Tempco on a resistor, right? That's not something you ever really think about it, except that when you have the possibility to tune that parameter, that's something you have to say. And so you start getting these like spec sheets that get incredibly detailed.
It's like you're like, oh, I want a power inductor that can do 4 amps. So you go to DigiKey, a power inductor with 4 amps, you're going to get like a DC of like a couple of milliohms.
Yeah, right.
But in China, you can get like 100 ohms. Because they're like, well, you didn't specify that. You just said power inductor, which doesn't mean anything, and you just said 4 amps.
Right.
So this can carry 4 amps, and I'm like, it's completely unsuitable for anything. And they're like, well, somebody wanted it at some time, so we do make
Clearly, it was useful for somebody.
Exactly.
Right? It might be useful for you, and it's cheaper, right?
Right.
We're trying to help you.
We're trying to help you. You said you wanted the cheapest possible thing. That's why you're in China.
Yeah.
So that is definitely what I like about this. Is not only is it you have the words, but you show the words that you need to have shown.
Right. Yeah, I try to get into some of the more difficult things to sort of like translate. Like I want a Zener diode or an ESD diode or voltages and specs and stuff like that. So a lot of these are actually even difficult for like the local people to translate and understand, because they get very technical, and a lot of the people in the markets will actually use colloquial terms to refer to the parts. Like actually when you go into like here in transistors, there's a term for them, jingtiguan, which means sort of like a crystal tube, which is the technical term for it. But some of the market traders call it sanjiguan. It's like a three-legged tube. It describes that it has 3 terminals.
Yeah.
And not so much that it has like silicon on the inside. And so it's funny, you talk to some people and you say, I want a Sanjiguan, a three-leg thing. They're like, what? And then you go to other people and say, I want the crystal tube. And they're like, what? And so there's like a lot of these like different subtleties that were really difficult actually to sort of capture when doing the translation guide. And so one thing I did in doing the translation is like I would first kind of look at what the official like academic translation was, but those aren't always useful because yes, you would find a paper or some official entry for it, but the market traders wouldn't use that term. And so then I would go find someone who spoke that particular dialect of Chinese, who trades with the market and run the things past her. And then she would sort of be like, no, these are the terms that they would actually use. And then I would drop those into the book, or I would have to make a judgment call. So what is the most likely thing that people would understand in that market? So some people will point out, like, oh, that word's not technically the right word, or whatever it is. I'm like, yes, but this is the word that's actually used in that context, right? Yeah. It's actually a bit of doing to sort of figure that all out. But yeah, and then there's a bunch of things to help you. Like this is a common thing. The sample is almost right, but I need something different. Like you pick something up and say, here's this switch.
But I want the actuator longer.
Yeah, I want it bigger or taller or longer. And so you can like point to the different things, and they could hand you different samples until you finally get the thing you're looking for. And then at the end of the day, the other really interesting thing about it is at the end of this book, I have here a bunch of business card holders and receipt holders. So you can go ahead and once you buy your part, even if you don't understand the words that were used and what people were saying, you can get the guy's business card, put it in here, get the receipt so you know how much you paid for it, and even put the sample inside the book and mark a little X where the guy was. So later on, when you come back months later, you forgot the part and the name and how much it was, you can like open your book and like
this is by the way, this is investigative journalism, right? This is like it's like a scientific sample book, like the pressed.
There's a press.
The pressed flowers.
Yeah. People can go in there and like find their little samples and put in the book and that sort of stuff.
It's like archaeology, right?
Yeah.
So you're digging through. So this is really. Do you use this book as well? Or?
I do. I mean, I wrote the book that I wanted to use and would use if I were there.
Yeah.
And then I wanted to make it available for other people to use because why not? And I also wanted to really use the book medium in a way that took advantage of it being a book. Like you could do apps and translation guides and stuff like that. And so here, like the idea is like you can mark on it and you can like write on it. You can tear pages out and hand it to the vendor.
I like the density. You can point and you can write on the back. Yep. Each page there's space to it. So if you want to make new types of boxes,
and you can and the whole thing is in a binder, like a ring binder. So you can just go around like this and not have it close up on you, and write notes on it. And then of course. This here is you get 10 of them, so you can go ahead and use them. And the idea is that you would essentially sort of every time I would do a project, I would open up another one of these books, source all the parts for that project, put them in there, and I would archive the book along with the project.
Ooh, that's a good idea.
Right? And then
buy multiples. See, support Bunny.
Yeah.
But that's a good idea. It's a good idea.
Yeah, but the idea is that like then I have like a record of the sourcing and all the things that was done with it. And when I want to go and do another production run, I just open the book, and all the notes are there. All the samples, all the receipts, everything's organized, as well as everything I need to go ahead and source it again. So I forget all the time. There's no way I can keep all that documentation straight. But here's a sort of a funny, interesting story. I built this with this idea that you would have a map of the district, and then you could ask people, like, where am I? Please point the map, all this sort of stuff. And I was talking to one of the local people, and she sort of chuckled at me. She was like, why did you put a map in here? I'm like, well, because I want people to say where they are. Apparently, they don't teach people how to read maps in China. That's actually not something that they do very often. And so I was wondering why I was having so much trouble getting people to like mark their location on a map.
There's no top view. It's just that's not that way it's conceptual.
I haven't fully understand the cultural phenomenon, but she was just like, there's not like, it's just not something that you do. It's not like learning how to read a map and navigate a road, like getting around with a map wasn't part of the curriculum, I guess, or whatever it was that people were taught. They would just know their villages, and they would like.
Yeah, you just kind of know it.
Yeah.
And it's like having a top-down view is not that useful because it's like, well, you just go to that hut near the tree.
Right, whatever it was.
You go to the farm and then you take a left.
Yeah, or whatever it was that how they would teach it. And so providing a lot of people would, when you say like, where am I, please point a map, they would actually laugh and then have to ask someone, and there'll be this whole like hullabaloo going in the stall, and they would try to mark a spot.
How would people say where the stalls are? Like you just don't. You say, oh, like
They would say this building, this floor, this number, right? The problem is the building is in Chinese, right? And oftentimes the stall name is in Chinese, and so it's not useful for someone who doesn't speak the language to find that again, which is why I want to introduce the concept of the map. But what it turns out is that oftentimes if you get the business card, it'll have all that written on it, and you can show it to someone.
A little bit like New York, I will say. If you said to someone, oh, I went to this, I went to this great restaurant. Well, what's the address? Oh, it's like 65th and 3rd.
Yeah.
And you're like, well, what's the address? It's like, well, like you get 65th and 3rd, and you look around and you just like find it.
Yeah. It's almost exactly like that.
Nobody really uses addresses in New York. It's like a very. Whereas like in Boston, like you would maybe, in Boston, like people would be like, well, where is it? Oh, it's in Central Square. Where? Well, it's like near the Middle East.
No, and no one had like say the square is Davis Square, Central Square, Union Square.
You go to Davis Square. Where is it? Oh, well, it's next to the used bookstore. Right. The used bookstore.
Right.
Oh yeah, the used bookstore.
Yeah.
So it's like not that unusual.
Yeah. So that's exactly right, and that's kind of how like that market like Hua Chumby kind of goes up. It's like, oh, you go to Hua Chumby building number 2. And you go like 2 stalls back, and there's a girl who makes cables, and can't miss it, right? You're just like, oh, come on, like
she's got pigtails.
Yeah, you're killing me, right? I really want to find this thing again 2 months later.
But it is tough to explain. Yeah, exactly.
And so really, funny. I think I'm going to keep the map, but I think I'm put a little annotation here is like, don't expect them to.
And you can't take photos with the marker. Right?
It's tough. Yeah, they don't like it. Well, and so here's a funny thing. If you bring in like a point and shoot camera, it's definitely forbidden. But if you have like
obviously your cell phone
cameras, they all have cameras. People do that all the time, right? And a lot of times you just ask like, do you mind if I take a picture of this thing? And they say no problem. And you can take your cell phone camera, take a picture of it.
Can you take a photo of their banner, or like that's kind of not?
Yeah, no, I think it's fine if you ask. I mean, I think a lot of it's just about consent, right?
Yeah.
And part of it is also just like not having the huge like they feel like when you
it's a little like, what are you doing?
Yeah, like what are you like? And there's a little
like people visit here, and I'm okay with them taking photos, but it would be a little bit weird if they had a telephoto lens and were like photographing every single thing. I'd be like, yo,
yeah. And so
it's all online anyways. What's the deal?
And I think there's a sort of a natural distrust of the media out there, and whatever it is going on.
Well, they've got like the hologram stickers that say Sony, right?
Yeah. So, anyways, yeah.
Okay, so
you got 2 more things going on.
Fun.
You just did a talk at CCC, and then you got a book coming out. So what's this talk about?
Yeah, so this talk is about making technology inclusive through Papercraft and sound. And so one of the things that I've been working on for the past few years that I haven't been talking a lot about, like on my blog and stuff like that, but I really deeply care about is the start of Chibitronics, working with G-Chi to try and get electronics out into the world into a different format using Papercraft. And it turns out that doing this gets a much more broad audience involved, right? It's a more familiar language, paper and design, combined with engineering, lets people who aren't just focused on the engineering piece to also excel and participate in the conversation. When you have classes where it's just about, did you get the semicolons correct? There's one type of personality that does really well at that.
Right.
But when you have a class where it's also like, what did you do with it? Why are you doing it? What you're designing? Who you're designing it for? There's a lot of people who are very thoughtful, very intelligent, and who can also use technology very well, who now feel very included and can be, participate in technology. And so we actually recently have been working a lot on. I have a little prototype.
Oh man, it's more overhead time. This is like the best.
Yeah.
So we have a prototype now of a product.
I love the light blue.
Yeah.
Nice.
This is one of the great. Actually, working with Dee has been like amazing. She's got such a good sensibility for design and human-computer interaction, thoughtfulness, and before I really started working with her, like green circuit boards were green, whatever it is. But she.
Oh, it's cheaper.
Yeah, but the details matter. They really do. They really do make it look good. And so we designed a microcontroller, right, that it's paper compatible. And so it actually has a rigid-flex format to it. So here is a flexible portion of the circuit board.
It's flex, but it's not as flexible as the other flex stuff. Interesting, it's exposed.
Yeah, and exposed. And the reason why it's exposed is we can put it on a clip like this, and you can go ahead and clip it onto like a circuit that you put into a book. So, this one obviously doesn't have the circuit in it, but the idea is that you would make the circuit in here with copper tape, and you just clip it on, and then you could power on the circuit using this form factor. And so you need the exposed electrodes on this side to go ahead and touch down on that. And
There really are electrodes. I mean, literally.
yeah, they really are electrodes. But then this is also it's flexible, so it's more easy to integrate with paper. Paper is like lumpy and not always flat, and so you need some flexibility.
Oh, and there's like a kind of a soft rubbery
Yeah,
material
to
here.
help make.
Is this a custom clip or is this an off the shelf?
This is custom. This is actually
really sweet.
no one's seen this.
This is
yet.
injection molded, really
This
nice.
is actually a 3D printed sample of what we're going to injection.
No way.
Yeah.
This is 3D printed.
This is 3D printed.
Oh, this is with a resin.
No, this is actually 3D printed.
With what? With 3D printer?
I
can't tell me. All right, fine.
No, I know. It's like I did it in China. I said, here's some CAD files. Can you?
This
make
is amazing.
Yeah. Yeah.
It looks injection molded.
Yeah. It looks. I can actually kind of see when I pull this back.
Sorry, this is like it's
You
not
can-
about
you
what
can,
you're talking about.
you
but
can
this is
see like the
they
underlying.
take
See,
that
like they had to
through.
like take back some of the black, so that's the color of the underlying material, and they had to like adjust like.
That's so nice.
yeah.
Okay. Anyways, I'm sorry. I got like
But it's-
totally.
yeah, but-
nice clip.
Yeah, it's fully functional. I mean, like it's really great what they do.
But this is a very unique interface. I've never seen something like this before.
Yeah, and so this is all G's brain. I mean, she thought of like.
She's so creative.
She's so creative.
I love she like sees something and she sees something different.
Yeah, and she really really thinks about like all like the labeling and like the iconography of like this being power. So you have like an intuition of the power, and she wanted the labeling to be clear and large, and like the alligator clip holes. Like she like really sweats the details and really wants to get it right. And I love working with someone like that who just cares so deeply about getting it right at the end of the day.
Okay. So you've got this clip, and you can clip this onto paper, and then you use like conductive paint.
Or you can use conductive paint or copper tape or any number of conductive media. I actually there's some copper tape over there if you know.
Okay, so copper tape, which is
This is actually
easy
from
to
the
get.
Novena kit, right? But yeah, this is copper tape.
Well, it's really useful stuff.
And then you can go ahead and just put this down onto paper.
I love copper tape as a crafting element because you can have so much fun with it.
Yeah.
You can make capacitive touch pads,
Oh,
or you
yeah.
can like it's like you can just wind something around.
Yeah, it's super versatile, and actually
And then when you clip it on, it touches.
yeah, it touches,
That's it.
and the tape we sell.
And then this
a
is
little bit-
roughed a little bit, so it makes better contact.
Well, so this is one of those things that we had to learn the hard way. The reason why we hatch it is actually to make it more reliable. It's a reliability thing, not actually to make it more rough. But
No, so it grips. It has more surface contact
actually,
points?
no. Actually, what it turns out is that if we made this solid copper, the grain boundaries tend to propagate cracks, and so as you would bend it, it would fail. And
Right.
so by creating this fine hatching pattern, actually, it somehow breaks up that.
It's like a live hinge.
Yeah, so it's a live hinge, and it actually
copper.
it's a lot more reliable. This is something we had to iterate like multiple times to figure out, and finally get it to this point.
You're like master of flex circuits now.
Well, I do a lot with Flex.
Yes,
Yeah,
yeah.
I do
Okay.
a lot with Flex.
So this clip called Love to Code, and so you've got a micro USB port.
Yeah, let's see if we can do a demo. Oh my God.
What? No way.
So the whole
I got
idea
pressure
here.
on you today.
Well, I bring out all the toys
I know
for
you like to show off.
No, just for you. Just for you. I normally wouldn't do
And the
this
viewers.
well,
Once every
and the
7
viewers.
years. We
I
get-
don't normally do a lot of these sort of demo things, but like I was so excited to come see you and I want to show you what we're doing. We want to catch up on everything. It's like,
Yeah.
bring all this over. We can geek out and talk about and all this sort of stuff. So one of the things about this is that we wanted to make this super simple to use, and one of the problems with sort of getting started in coding is you have to install a bunch of drivers, which can be frustrating. You have to download a bunch of stuff, and it may not work. And another thing we're finding out is that a lot of kids don't have laptops. They get smartphones and tablets instead of hand-me-downs from the parents. And so if they want to do a homework, they don't actually have access to a laptop.
Yeah.
And so getting code from a smartphone into a microcontroller is, I think, really important for teaching kids. So we found a way to go ahead and get code from almost any web browser into here by using sound.
Yeah.
And so I can power this on. So we normally this is a USB connector which you would plug into
It's
a
an
computer.
on-the-go adapter.
But this is an on-the-go adapter, so I can plug into my phone to power it. So you have like this little phenomenon going here. And so now you can see this is turning on. This is running just like a little demo routine here. And actually, one thing that's really cool about this, do you see how it's doing this fading here?
Yeah.
This is actually, the demo is demonstrating multi-threading. Each LED has an independent thread
Oh, nice.
that gets fired off by you flipping a bit, and the fading is all independent. So you could go and change the fade. Like normally, if you want to code this
this is
like
a
we did,
pain,
it'd be
yes.
super hard to get all these right. But because each one's an independent thread, they all manage their
What real-time operating system are you using?
running Chibi OS.
CBS.
Yeah, which has nothing to do with Chibitronics, but it's a full multi-threaded real-time operating system. And so this
Chibi
is
just means small in
small and cute in Japanese,
Japanese,
right?
yeah.
So this is actually the multi-threading code demo here, and I don't know if you guys can.
Yeah, you can see there's code.
And
What's
so-
this
and so-
like?
and so-
C-like language.
This is Arduino actually, but
Okay.
we have extensions for threads in it, and so you can see that the loop here is just a for loop where we just iterate through blink, and every 500 milliseconds say blink a thing, and then here's each of the independent threads for each of those things. You can see that we do an analog write going up, analog write going down, and we turn it off, and that's it. That's how we implement the whole thing. And if you hit upload on this, it goes to the cloud, compiles the code, and downloads an audio file. And I don't know if the users can hear that, but that's actually what the code sounds like once it's compiled.
And it sounds like it's trying to do some sort of synchronization.
So
It
yeah,
takes
so
3 times.
so the first little sound is I call it the herald packet that says data's coming and gives it time to erase the flash. And then you can get that's actually 256 bytes at a time,
That's
right?
funny.
And it plays itself over 3 times because it's unidirectional. Sometimes, like if you're uploading and you get a notification sound, that'll bork,
Da-ding, yeah, right.
that'll bork a packet. And so we send it 3 times over just in case there's a problem. And so I can plug in the headphone jack into here, which now goes in this thing. And I can say, for example, let's change the
speed.
the speed. Okay,
That's
so
easy to see.
let's make it go a bit slower. Well, let's try fade rate.
And are you sharing the data pins or are you using the ID pin?
So we're using the ID pin for
Yeah,
the audio.
ID
the 5th pin. Yeah. So let's go ahead and
That poor ID pin is like,
change
this is not what I've been meant for, but okay.
Let's make the delay longer.
So when you say it sends it up to the cloud and compiles it and sends down like a sound file, essentially,
Yeah.
what is the compiler? What is it?
It's GCC.
Okay, so
Yeah,
you're just
But it's
sending.
running on
Yeah,
a-
yeah. The thing is, we couldn't put GCC in the browser itself, and so we have like this Docker image that runs on a server. It's actually located in Singapore right now, and it just compiles, sends back the binary, and then all the modulation happens in the browser itself to sort of save bandwidth.
Yeah, Microbit had to do this weird trick where all the code was in the browser and then they give you a hex file.
Yeah, what's neat
Okay.
about what they do is they actually, for MicroPython, they have the MicroPython runtime as one part of the hex, and then the code that you write, they append it to the hex file and send you the whole thing.
I see.
So you always get the latest runtime because it's
I
like
see.
they're not using audio, so it's like it's very
Right,
fast.
right.
So like fuck it, just send you the entire. You just send you the entire runtime.
These
You're done.
workarounds,
Nice.
so we can
Yeah.
use browsers.
So here I've changed the delay
So it's
level
slower.
already. So it's
Okay,
no.
make-
So the dimming effect is longer. So now you can see like 3 of them turn on at a time
3
instead of
times.
2. But let me actually change the rate at which things are going. So I will make the run faster. Let's say.
Yeah.
Let's make it run at 3. Let's see how it looks. It's and so you have to change it in 2 spots. The program,
hit the
so
button.
you press and hold, the light turns red, and then it uploads. You can see the light flashing as the packets come in.
That's fast.
And
Oh,
now-
wow.
And
That was really
it's
fast.
programmed, and so now it's moving. You can see that
It's
it's
faster than like downloading to an Arduino.
it is. We actually, so we had this thing we called the patience of a child constraint. Kids like lose interest if it's not very fast.
Yep.
And so we actually preload about half the common routines inside the chip. So digital write, digital read, bunch of pin mode stuff is all in there. So the actual amount of code you have to upload is really small. And yeah, it uploads super fast at the end of the day. So that's a little bit faster. Let's see if we can even get it faster still.
Neat.
And you can see like the blinking effect. You're now getting multiple LEDs on at the same time. Let's see what happens when I make it like that fast. I've never tried to push it
Uh-oh.
to super fast
I'm gonna
rate.
push
but
it.
Upload it, compiles, and there you go. And there you go. And it
Yeah.
now it's like super fast. It's just like
We're zooming.
going back and forth, back and forth. Yeah. So there you go.
Okay, so if folks want to find out more about this, so you'll probably have something on your blog.
Yeah, I haven't done the full blog post on it, but actually that link I had for the talk on 3D3C that had like goes into like actually the whole philosophy behind it, why paper is so important, why inclusivity is important, why we want to do this, and how we're going about it, and a lot of the technical details, meaning how we do the auto modulation and the packet format, all that stuff.
Right.
Yeah. So this will all be open sourced, and we're going to actually have a sort of like a closed beta, or an open beta, after Chinese New Year. Basically,
Yeah.
we're going to do the run, and people can go to the website and actually get these parts and start playing with it. But we really want to do a lot of testing and make sure we get it right first before.
What I think is neat about this is bonded onto.
Yeah, it's Rigiflex. It's actually
really
a
interesting.
it's a real Rigiflex process. We had to sit down with the Flex PCB manufacturer, because normally this is really expensive stuff. Like if you quoted this out and wanted to get this done in small quantities, you would pay like $10 for one of these. There's no way you could put it into like a hobbyist thing with after you put all the markup and margin in. And we managed to reduce the price by like an order of magnitude. There's a lot of actually, if you look at the design files, there's a lot of subtle, interesting things we did to improve the yield on this. So essentially, its first run working and reduce the number of process steps.
Yeah.
So that we could actually get like Rigiflex form, which I think is really important to make it work. For example, in this clip form, to be able to just wrap it around.
Yeah, I think the clip form is what it's kind of the magic. It's like it's a new.
You can just take it right off like that, and you can put it right back on. So
Different colored clips and all sorts of things.
yeah, different color clips, and if the board breaks, you can go ahead and put a new one on your clip, and blah blah blah. You get different. Yeah, so those.
We'll have these in the Adafruit store when you're ready for us to
sure we
stock
will.
them.
Oh yeah,
Yay.
sure.
So that's what you're working on now. So that's the latest.
Yeah,
So this is fresh off the.
This is so recent that this is the prototype I'm sending to G on Monday.
Wow.
And I was going to FedEx it today to her, except that I knew I was going to do this, and I was like, well, I'll bring this along and show it.
This is
off,
really neat.
And then Monday I'll send it to G, and she'll get to play with it.
Okay, cool.
So this is like super hot off the press.
All right, so in a couple months, maybe people will be blogging about this, and I love seeing all of these educational platforms. Like there's something that happened in the last year or two where like suddenly we have all these, the web technologies, the microcontroller technologies, the processes, like everything's kind of coming together where everything's getting low enough cost if we can actually get it to kids for like
Right.
$20 or less.
Right.
Like it's actually we're finally hitting that point. And like you and I remember like when I was in school, all we had was like $60 basic stamps.
Yeah.
Like it was rough.
Yeah.
And they broke really easy.
Yeah, and they were fussy to set up, and you had to have like
fussy,
programming
and it was-
dongles and all
Yeah, you had
this.
like an RS-232 port, and
yeah.
so it's like you had to use Windows. So now it's actually there's finally, like you said, it's like we're finally hitting this point where the technology and the pricing is just right.
Yeah.
Where
yeah.
you can finally do enough to have the performance you want.
Yeah. And we can also get to the point where we can ask like, not just like, can we get the program, but how do we make it easy and fun and engaging, and like really focus on the user experience and the
like
curriculum.
it's only been like 3 years of like we no longer have to dick around with USB stacks. Like the microcontrollers come with USB stacks, but like 4 or 5 years ago, you'd have to write this all yourself.
Oh yeah, and actually, funny thing is so this thing can talk to the micro USB, but the microcontroller itself doesn't have USB, and so Sean wrote a BitBang implementation of USB, and he has actually a great talk at 33C3 where he talks about all the details that goes into writing a BitBang USB stack. But he's wrote all that, and it's open source, and you can look at everything that goes into it. And so one of the neat things is that you can plug this in, and it will recognize, with the right code in it, recognize it as a keyboard.
Yeah.
And this can do like the whole touch thing, so you can do like a little kind of
keyboard thing.
like keyboard thing. Touch the pins, and you can like craft your own little switches out of copper tape, clip it on.
You know what I like for I really like for HID, which is funny. It's not what most people use it for, because a lot of people are like, oh, you can do a makey, but actually it's really useful for accessibility, because you can have really big inputs or like things that are easy to touch. So I hear a lot from people like, oh, my kid wants to like play a game, but they can't hold the controller, even if it's a very simple game. So they make, they can use conductive tape to make very big contact that the kid can slap, and even if they don't have like really strong motor control.
Nice.
So HID, because almost everything uses a keyboard or mouse, HID is a really nice way to interface with a wide amount of software.
Yeah.
Because it already has
Yeah,
keyboard.
yeah. I love,
Keyboard is one of my favorite like interfaces,
Yeah.
definitely, because it's so universal.
It's so universal.
Like they
Yeah.
came up with something, thank
Yeah,
God.
yeah.
And Bunny, you have a book coming out.
Oh yes, the hardware hacker.
Hey, you're
right?
busy.
Yeah.
We have a uncorrected proof. Thank you for
But it's perfect.
thank you for sending it
there's
to
still
us.
bugs in it. Yeah, no. It's actually No Starch who's took on the task of compiling, editing, printing, all that sort of stuff. So this one's different. So the essential guide is self-published by me. This one here is No Starch Press, and these guys are great. Like I said, they did hacking the Xbox and all that sort of stuff, and they were kind enough to create a bunch of galley proofs and send them around to people. And I said, you've got to send some to Lemore and Phil.
Yay.
So
No, we read through it.
Yeah.
And we're like, hey, we remember this.
And this
some
is
of
your
these
journey,
things
and
I
this is
read.
just
You had an interview?
yeah. It's just
Yeah.
it's your story, and I think what's interesting is if you read like a lot of old scientific texts, the discoveries are always great, but the journey and the thought process and imagining yourself doing something like that, I think that's where we can
yeah.
grow our community and do more.
Yeah, yeah.
And that's what I liked about your book. I can imagine like the thrill of some of the things
Yeah.
that you've done, not just the end, but the journey.
Yeah,
And
and
so-
I also like documenting the failures too. I mean, I think
Yeah.
it's very important because the problem with scientific papers, a lot of them is like, here's point A and here's point B and here's the shortest path to them, and we're going to write about that. And you look brilliant, like you figured it out. And actually, what it was is you failed until finally you find like the
Right.
shortest path, and then you look smart. But really, this is a very iterative process. We screw up all the time.
10-year overnight success. Right?
Yeah, and one of the things I liked about when Bill sort of framed the project to me and wanted to put this all together is he was, he put it together in an arc that really was, I think, more genuine and was able to go into all things so that people would learn and say, I want to do an adventure like this. What does it take? And then A, they could read about my failures and avoid them. And B, then they would be more prepared to move forward and make progress beyond where I went.
Make their own unique failures.
Yeah, but that's the whole idea, right?
Yeah.
Why repeat failure, right?
Exactly.
So
Okay, so if folks want to get that, they can pre-order it on Amazon.
yeah, it's pre-order. I think it goes live in February.
Okay.
And so yeah, I'm excited that Bill put a lot of effort into the book and got
Yeah, this is awesome.
a lot of people to edit. It's a lot of editing went into the text, and there's some new material in there that hasn't been seen by anyone
I love how
else.
it's just a mix of like about mechanical engineering, electronics, and law, and society, and culture, and then you're like, okay, here's my injection molding tips and tricks. It's a smorgasbord.
But that's the whole, and that goes back to the whole idea of being a hacker. You see through the abstraction layers. Law is just
it's all the same thing.
Yeah, law is just another part of a system that you can use to get things done, right? It's not, and then injection molding and hardware and software, they're all bits and pieces you can put together. And I think that's the essence of hacking. Is just there are no barriers, right? You just use the pieces as you need to use them to get the things done you want to do. And then there's always the question of why you're doing it and should you do it or not. And that's when sort of the ethics and stuff come in. And so that's part of the stuff I cover in here is here's my ethic and what I believe in, but here's a whole set of tools you can use to get what you want done.
Okay, so for folks who want to keep up with the latest and greatest, there's two places that I have to say I visit every day. It's looking at my RSS feed to see if you've updated your blog.
Which I do very rarely.
You do, but you have
You do, but when you do, it's
you have
really
to name
good.
you have to name them where every month,
Yeah,
which is great.
yeah.
And then you'll announce stuff. And then also on Twitter, you always have something interesting. We saw people decapping iPhone 7 processors. You have
Yeah.
this UV curable
Yeah.
solder mask.
Yeah.
So you're at Bunnie Studios,
Yep.
and then your blog is bunniestudios.com.
Yep.
Okay.
Yeah.
So,
Keep up with the adventures.
all right. Well,
Thanks.
Lots of adventures.
Bunnie, thank you so much.
Oh yeah, no, thanks for. I mean, it's great.
Never boring.
Yeah, it's great to catch up and see what's. I mean, the other thing that you're not seeing in this is we went around all day and Lemore's telling me about all the cool things she's doing too, which is
Yeah,
this
but
huge
everyone-
volume
everyone
of
sees
stuff,
this
and
stuff,
so
boring.
and so it's not I am in the presence of greatness and I'm
Awesome.
glad to be able to share the things I'm doing with you.
Bam.
So.
Okay. Represent.
All right.
Good stuff. Good times. Make cool art. Fight like hell.
Yeah.
All right. Thanks, Bunnie, for
Yep.
joining us
Cool.
on this adventure.
Thanks.
All Thank you, everybody.
Pick
Yep.
up his books.
Hooray!
Pick up his electronics. Support this. You like this? Support it. It matters. No, it does.
Thanks.
Not just, I mean, talking is great, but also helping him keep doing this thing.
Bye-bye.
Thank you.
All right.